Kia ora Year 11. This video is going to go through a bunch of old MCAT problems where we've got equations with exponents. And so the big idea in every single one of these is that when we're working with exponents, it's really useful to have the same base. So I'm just going to basically blast through 5 of these, and I'm going to go reasonably quickly because this is a revision video. So let's look at the first couple from 2023. Well, we've got to solve 4 to the power of x minus 2 times 2 to the power of x plus 1 is equal to 32 to the power of x. Now the first thing to notice straight away is the bases aren't the same, but they're all powers of 2. So we're going to start by rewriting. I'm going to put the powers into brackets, and now we're going to have 2 squared to the power of x minus 2 times 2 to the power of x plus 1, and 32 is 2 to the power of 5. And once you've done that, the problem starts to get much easier. So remember from year 9 that we multiply those powers together. So 2 to the 2x minus 4 times 2 to the x plus 1 is equal to 2 to the power of 5x. And now we've got the same base, so we can just add the powers, and we get 2 to the power of 3x minus 3 is equal to 2 to the power of 5x. Right, now the next step of logic is that if the bases are the same, then if those two things are equal, if this is equal to this, then the exponents or powers must be the same. So we're back to solving a really simple linear equation. We've got x on both sides, so negative 3 is equal to 2x, x is equal to negative 3 over 2. And that's the pattern of solving that we find in a lot of these MCAT problems. Sometimes they get a little bit more complicated and we might end up with a quadratic to solve, but I think not in the 5 in this video. Right, the next one is very similar. Okay, so I'm going to write it down, and then if you can pause the video and have a go at it, remember that putting brackets around can make your work, can make it much easier to see what to do next. That is a time sign, not a plus sign. Okay, so changing these to be powers of 2, we get 2 to the 5x minus 2 times 2 squared to the power of x plus 2 is equal to 2 to the power of 4 to the power of x. That gives me 2 to the 5x minus 2 times 2 to the 2x plus 4 is equal to 2 to the power of 4x. Now we're going to add these exponents together. So we have 2 to the power of 7x plus 2 is equal to 2 to the power of 4x. And we can now equate the powers because the bases are the same. So 7x plus 2 is 4x. 2 is equal to negative 3x. And that gives me x is equal to 2 divided by negative 3, which we write as negative 2/3. Okay, because remember the convention is that if we have a negative divided by positive, we write the negative in the numerator. Right, what's next? Let's see. Okay, so in this next one, we have something slightly different. We have this 3, and then we have this, and we have this 24, and we're not loving that because that's not a power of 2 or 3. So let's see how we can think about that equation. Well, the first undoing step in here is to divide both sides by 3. And then it becomes very easy after that because we get 2 to the 4x minus 5 is equal to 8. So 2 to the 4x minus 5 is equal to 2 cubed. And again, we're back with the same base, so we equate the powers. 4x minus 5 equals 3, 4x equals 8, and that gives me x is equal to 2. Right. Question 4. Now this wording is a bit funny. Find an equation for P in terms of Q if this is true. Sorry about the barking dog. It's not the maths, it's someone walking past. Right, let's have a look. So we have to here, first of all, get everything into the same base, and then we're going to end up with P is equal to blah, blah, blah. and this will have q's in it. Right, so 27 times 3 to the p plus 2q is equal to 9 to the power of 3q. Again, we start off by changing that 27 to 3 cubed. We'll leave this alone. We might pop it into brackets, and the 9 is 3 squared. So we do a wee bit of cleanup. We've got on the left-hand side over here, we've got 3 to the power of 3 plus p plus 2q is equal to 3 to the power of 6q. We've got the same base, so if this is equal to this, then the bases are the same. That means that the powers must also be the same. So 3 plus p plus 2q is equal to 6q. And remember, we were asked to write p equals blah, blah. So p is equal to 6q minus 3 minus 2q. Just undoing these things. That gives me p is equal to 4q minus 3. Right, one video left. One question left. And it's another one where we've got to make the bases the same. So it's this one here. And you can see from looking that this one is probably the easiest of all of them because we just have to change that 16 over. Right, 2 to the 2y times 2 to the 2y minus 12 is equal to 16. We can clean up the powers on the left-hand side, so we get 4y minus 12, and 16 is equal to 2 to the power of 4. That gives us 4y minus 12 equals 4, 4y is equal to 16, and y is equal to 4. So there you go, a short video, but I've got a bunch more of those to do, but I'm going to split it into two. Email me if you've got any questions on those. Remember, always get the same base on both sides, and be careful with your rules about multiplying powers together and doing powers of powers. Thanks for watching.